Good afternoon and welcome to Ghidra, Journey from Classified NSA Tool to Open Source. We're in Islander EI, and we have Chris Delikat and Brian Knighton presenting today. A couple of notes, stop by the business hall located in Mandalay Bay, Oceanside Shoreline Ballrooms on level 2. The Black Hat Arsenal is running in business hall on level 2 as well. Lunch will be served in Bayside A and B between 1 and 2:30. With that, I'd ask you to silence your cell phones and welcome Chris and Brian.
Thanks.
Hey everyone, thanks for coming. It's a big honor to be here. Speaking for NSA, the Ghidra team, and myself, it's a big honor. When we first started the process of moving to classified and open source, I sort of made a joke like, hey, we should go to Black Hat, like sort of thinking it would never happen. But but here we are. So it's pretty awesome. So thank you. So for some introductions, I'm Brian Knighton. I'm a researcher at NSA. I've been a Ghidra developer since about 2001. Currently, these days, what I do is what I call applied research, where I'm doing IoT VR for various things. I'm gonna turn it over to Chris now, and then we'll come back and talk about some other parts of Ghidra.
So hi, my name's Chris. I'm a tech lead in research, which means I guide a lot of really cool cyber projects. I'm not on the Ghidra team, but I've been working with Brian for many years. We've collaborated on a lot of different things. And he basically brought me here to talk about all the stuff he doesn't want to talk about. So, such as the agenda. We're going to start off talking a little bit about the origins of Ghidra and putting it in context with NSA and research at NSA and kind of how that makes sense and why we did what we did. And then a little bit about the background of the tool and some more information about features and why we sort of felt like we needed to have a tool like this built in-house. And then we're going to go and discuss the framework, why we call it a framework, what it really means, and there's going to be a lot of cool screenshots there. And then we're going to touch on some more open source aspects of it and all the little things that we had to do to kind of bring the tool open source and what it means to do that. And then at the end, we've tucked away some new features and metrics to kind of hopefully keep people in their seats till then, and it'll be real exciting if you can make it that long. So I thought it'd be fun to do a little bit of jargon that we have. Not all of this is specific to NSA, but like any other professional organization, we've got some words and phrases that we kind of use internally, and we're going to probably be saying certain things. I figured it'd be good to kind of get some stuff out there. So software reverse engineering, SRE, if you're not familiar with the tool that we're talking about here, Ghidra is a software reverse engineering tool. I'm going to talk a little bit more about that in a bit, but just so you see SRE, you're going to see that, we're going to say that. VR, vulnerability research, is something you do with a software reverse engineering tool. Cyber, it's one of everybody's favorite words these days, right? Cybersecurity. When we say cyber, I guess we kind of mean computers, computer networks, that sort of thing. It's almost become synonymous with the next thing, which we call CNO, computer network operations. That's kind of a government abbreviation that we like to use to describe cybery things, cyber. And so then there's the IC. We're going to say that quite a bit too, the intelligence community. That's where we're from. There's about 16 entities within the intelligence community. And we'll say things like, the releasing of Ghidra was good for the IC, or this whole process supports the IC. Unclass is a word that we use, a sort of abbreviation to say unclassified. It means something that it's not protected as under classification any longer. And that's kind of, part of the journey of Ghidra has gotten us to that point. And NSA mission, these are we're going to hear us say these things. Mission is kind of like the goal, the point of what we do, why we do what we do. And when you hear me say something like, I do cyber SRE for the CNO mission and the IC, now you can understand what I'm talking about. So here's NSA Headquarters. This is a little bit about the NSA, in case everyone's not completely familiar. National Security Agency is part of the Department of Defense, and we have a bunch of missions that support cyber type things. We are in charge of supporting and securing national security systems, and that is systems that contain classified data and are used in the conduct of intelligence and military operations. We also support our leaders with information, provide decision makers the information they need to sort of make policies and decisions. We also work with industry to secure critical infrastructure, and that's different than different than national security infrastructure in that it's the public infrastructure, critical systems that help society keep going. Think about power, water, that kind of stuff. And finally, we support the armed forces, and we work with them with cyber indicators and other things of intel value to kind of help them do what they do and protect them. And so with all these cyber responsibilities, you kind of imagine that we've probably got to have some tools that we've developed to help us with all our cybering, right? And so that's where Ghidra comes into play. But where did Ghidra come from? This building up here, this is the headquarters for NSA Research. So where Brian and I work, we go in there every single day, except the weekends.
Not weekends.
And so you think for a second, what do you think of when you think of research? What is research? A lot of people, research just means something like you're Googling around, maybe reading some articles, looking at Stack Overflow, looking at some code. But I'm thinking, I'm going to ask you to think of what at an organizational level research means, right? And so in some organizations, research is a means to sort of analyze a specific activity or technology for a specific defined amount of time and then produce some kind of a paper at the end of it. In other organizations, you want to take some technology and try to push it to its limits and develop some proof of concept. At the NSA, it's not exactly either of those that we do. We do what we like to call mission-oriented research. And so back to those missions I mentioned earlier, our goal is to impact the mission in a positive manner in whatever the time frame necessary to do that. So it gives us flexible time to do whatever we need to do that we think is going to impact the mission. And some of those things you can see how Ghidra kind of fits into that, because as we've announced, this has been an ongoing project within research for many years now. Other projects in a similar vein would be SC Linux, where we worked on that, and the mission was sort of to help critical infrastructure and secure that. And so maybe you're asking yourself now that I've said this is about research, why does NSA have an embedded research organization? Why don't they just farm the things out that they want? Well, there's a quote I like to use to kind of illuminate what it means to have an NSA research organization. And so there's an American inventor, Henry Ford, who's credited with the invention of the automobile. He supposedly said something along the lines of, if I had asked the people what they wanted, they would have said faster horses. And so what that means in this context is, a lot of times the organization or the individual that needs the innovation doesn't necessarily know exactly what they need. They can only see so far ahead of themselves and see essentially, I'm doing this now, give me more of what I've already got to kind of help me complete what I'm doing, and don't have the ability to kind of step back and figure out what the real problem is. So at NSA Research, we're embedded within NSA, and that gives us the ability to sit side by side with our operational entities, learn their problems, and then take a big step back and not have to be beholden to the operational day-to-day, and we can come up with innovative solutions that they never maybe even thought of, right? In the case of faster horses, we can come up with a car or something else that gets them what they need. Another cool aspect about NSA Research, and this is a shameless plug for working in research, we're our own directorate within NSA, which means we're not necessarily beholden to requirements from any other org. We have the mission to positively impact operations, obviously, but we can do it in our own way, and it helps us to kind of, it gives us a lot of freedom to think of solutions that we're passionate about. And we can do things that we're interested in rather than having requirements given to us to say, do these things. We can come up with ideas. Sometimes they fail. One of the best things about being in research at NSA is we have the freedom to fail. And failing is just really figuring out one way not to do something. Sometimes you figure out a lot of ways not to do something, but failing's okay, and we like that aspect of it. And so, why is, I'm going to talk to something that's not exactly on the slide, but you can look at those facts up there while I say, you may be asking yourself, why is Ghidra still in research, right? And like I was saying before, the mission-oriented research we do isn't meant to sort of have a beginning, middle, and an end. There's not a time span, and there's no paper that we're going to write at the end of reverse engineering and say, we researched it, and here's the result. What Ghidra is a tool that's been built to be a framework or a foundation to support future research. And having that entire system in-house gives us the ability to turn the knobs and twiddle the screens and do whatever it is we need to do to support exactly how we want to make that work. And having an external tool, we wouldn't be able to function in the same manner. And so now Ghidra is a platform or framework that can sustain next generation vulnerability research, different kinds of binary analysis, program analysis, and all kinds of things that we haven't even thought of yet, but we're keeping it in-house for those reasons. And so, as I mentioned earlier, the software reverse engineering, why would we even do that? What's the point of it? Not everybody sort of does software reverse engineering, so I want to explain a little bit about that as you know, so you can follow along. Ultimately, it's to find out what's in your binary. Software reverse engineering is you have a binary, you're taking it, and you're going to look at it and try to figure out what it does. Why would you want to do that? Well, there's a couple big cybersecurity reasons I can think of. Number one, you've got a binary on your network or your computer that you're using, and you want to look at it for the vulnerabilities that may be in there so that you can defend yourself from them. You don't know what's in there, you don't have the source, you just have a binary. Maybe you bought it, maybe it's part of the operating system, who knows? It's there. Another reason why you might want to use a software reverse engineering tool like this is you have a binary on your network, but you didn't put it there. You don't know where it's from. Maybe it's malware, maybe it's not, but you want to figure out what it's doing there, where it came from, and what maybe it's done to your network already. And so in 2000, there weren't a lot of tools that did that type of thing, and there were really no tools that had all these features that we're looking for here. And so I'm not going to talk to every one of these, but some of the key things that we were looking for back then that were not addressed by anything on the market. We were doing collaborative reverse engineering in a way that was not really addressed by existing tools back then. Teaming, multiple people working on a single binary and sort of reversing different parts of it. Then we wanted to have a lot of extendability and integration for different tools to sort of improve the overall workflow by putting a bunch of things together that make the reverse engineers, life a little bit easier. And then obviously undo redo is a feature that's sort of critical when you're looking for a way to sort of analyze a binary that you don't really even know where it came from. So you don't really know, you're probably going to go down a lot of false starts and then dial it back and have to do other things. And then headless automation, right? We want to do that too. You can run a lot more things if we can run stuff on the side, run in the background. And so what this chart is, don't look too closely at the numbers. Not sure what exactly that means, but ultimately we're trying to show here is that software over the years has been growing in size. And not only has it been growing in size, it's been proliferating and working its way into everything that we have, right? And so there's vulnerabilities and malware potential I was talking about earlier. That's growing too. It's just everywhere. It's all, software. Every software we're using is getting bigger. There's more possibility for vulnerabilities, more possibility for malware, and the networks are connected. So there's more possibility for stuff to get everywhere. So this is what we sort of anticipated, and part of the reason that we want to get this tool out so everybody can start using it and help us and help the community get better at reverse engineering, because this is not a skill set that is going to diminish, and it's not something we're not going to need in a few years. It's something, if anything, we're going to need a lot more people with that skill set in a few years. And so I think at this point I'm going to hand it back to Brian.
Think so?
You ready?
I am ready. Are you ready? All right. So enter the dragon to sort of solve all the problems that was outlined by Chris. So thanks, Chris, for going over that. So Ghidra is our sort of our solution that we came up with to solve all those cyber issues of scaling the teaming. There's been a lot of questions about what Ghidra stands for, where the name came from. So I'm going to give you a big opening reveal here. Since we use lots of jargon, unfortunately, I'm just kidding. That's a joke. This is a joke. What Ghidra actually stands for is what you think. It's the three-headed monster, right? It's because we were trying to bring together three things into one body of knowledge, one body of work. Three key features that we had in terms of our research requirements when we started on this was to have scaling, teaming, and extendability all in one environment, one framework or one tool. And we also wanted to bring together, because before Ghidra, you would have your hex editor open as one application. You would have your disassembler in one application, and you would have, say, a debugger or some kind of other emulation system as a separate device, and they weren't all working together. So we wanted to bring all those together, hence the three-headed monster. The three-headed, that's where the name comes from. So let's do a quick run through of some of the major features and see how Ghidra kind of flows. So the first thing that makes Ghidra unique and different is that it's project-based. So instead of just bringing in one binary, you actually create a project first, and then in that project, you can bring in all the binaries that you want to look at. So in this case, I brought in, say, bin CP into my project, and because that's the binary that I want to look at. We also call this sometimes just our front end. We'll say, open the front end. That's this window right here, but it's technically the project window. We call it the front end because if you look at the code, it's called the front end plugin, if you check out some of the code base. So once you have your binary brought into your project, you can then open it up in this first window, which is the listing view. This is where you do all your annotation and mark up the binary. You create your instructions, you create your data, you lay down your comments. This shows the function as a linear flow of addresses. So as you're going down, it's flowing down through the address space. So if you have a function that's not contiguous, it's broken up, we have another view that will render this as a graph. So we have a function graph, which is giving you the same information as the listing view, but it breaks it up by control flow. So here's the one function we were looking at on the previous slide, but it's showing each control flow block. So it's split up by transitions, jumps, branches, things like that. And the way it's organized is actually by dominance. So a node that's is below and to the right of another node means it's dominated by that other node. Meaning, so like you can't reach that node unless you flow through that, through the node that's up or up and to the left of it. Down the bottom right-hand corner is an overview, because you can zoom out if you have a really complex function, and you can see like just a small piece of a larger function. And the bottom right-hand corner will show an overview of that. Then the same view that we just looked at before, but we also have a decompiler that will take that assembly code and decompile it into a C-like representation. The cool thing about Ghidra is the decompiler will work on any architecture that we support. And by support, I mean if we have a SLAY processor definition for that architecture. SLAY is what we use. It's a text-based grammar where you can outline the architecture, you define the registers, the instructions, the P code, and the P code is what we call the microcode for an instruction, and that's how we can actually decompile it from the assembly code back to a C-like representation. It goes through a few steps in the middle, but generally speaking, that's how that works. Another cool window that we have is the file system browser. This was introduced, like later on after Ghidra was created, and it was designed to be able to tear apart and open firmware inside of Ghidra. So instead of just bringing in one file, you could have a tar file that has a bunch of binaries in it, and you could open that up inside of Ghidra and sort of alleviate the need to have an external tool to unpack something, okay? And there's a bunch of formats that we support. The other big feature we have is the script manager. This is really awesome. You can basically configure Ghidra through the script manager to do anything you want. You can automate things, create new analyzers, lay down code, comments, find functions. You can write scripts in Java and Python. Fun fact is that when we first added this, we actually didn't have support for Python. And someone was like, Java, I hate Java. Why'd you do Java, right? Which is kind of a theme. We've heard a little bit about Java. And so one of our users actually added the support for Python. So if you wanted to say add another language, say Ruby, you could drop in an extension to the script framework and support other scripting languages as well, as long as it has some Java connection. And then bringing it back to the three-headed, like three things working together. Here's the same three views we saw a moment ago: the listing on the left, the decompiler in the center, and the function graph on the right, and they're all working together. So if I make a selection or make a change in any of those windows, it'll propagate over to the other windows. So if I wanted to see, this if statement here and see where which blocks it's associated to, where it is in the listing, in the bytes, are they contiguous, are they not, as well as in the decompiler, it'll show me the transition points. Okay. We have a bunch of other features other than just that. We have an assembler that allows you to, inline in the listing view, write new assembly code. We have bookmarks, which are just what they are. You can lay down little breadcrumbs at a place. We have a byte viewer, which is what we call our hex editor. It's kind of like a hex editor, but you can kind of do a little bit more than just change the bytes. You can do them in different bases, ASCII, and all kinds of things. We have a data type manager that allows you to create union structures and apply those down on your binary. We have an entropy window. This will show you how similar or different your bytes are across a program. It's really good for figuring out if a program is compressed, say for example. We have lots of ways to do navigation and searching. So like you can move around your binary pretty, in a multitude of ways to make finding things much quicker. Version tracking is a really cool feature. So if you've done some SRE on version 1 of a binary and version 2 has come out and you want to move as much annotation forward as you can, because you assume that not everything's changed between 1.0 and 2.0. Version tracking is used for that. Version control, that's our multi-user. So like if you're looking at a large binary, like you can collaborate on it. So I say, no, I'm going to do the first 10 functions, and you do the second 10 functions. So it works out really well. So now let's talk about some of our code base and how we implemented some of the features I just talked about. So our code base is split up into sort of 3 high-level categories. Framework, which is the base GUI and storage components. We have our features area, which are all of the SRE-focused plugins and scripts that are specific for doing SRE. And then we have all of our processors, which are all of the SLA grammar specs I told you about for defining the architectures that you want to disassemble. So let's talk about the framework a little bit, because this will kind of help understand why we call it a framework, and it's not just a tool. So the framework has 5 main components, so let's kind of go through those. So the first one is DB, as our database. We call it a database, but it's probably not a true database because although we have tables, rows, and columns, it's not really SQL, like you can't run SQL statements on it and things like that. But we created it at a time when there really wasn't any good Java database, because it was a long time ago that we made this. But it was created so we could support natively at a very low level the undo, redo, and the version control. All of that is layered on top of the DB component. Okay. Now the model portion of the framework it's from like model view control from software design. So that's the model. It's the data that's inside of the project. So a project contains 1 or more domain folders, and each of those folders can have 1 or more domain files. And a domain file is bound to what we call a domain object. And we have 3 implementations of domain object that's included with Ghidra. One is program, which is all of the storage for storing a program, all the program's information. We'll see that in a minute. We also have data type archives. So you can make bundles of data type archives and share those across users in your multi-user environment. And version tracking sessions. So if you start a version tracking session, you can save that and come back and do it later. So part of the reason why we call it a framework is you could create other domain objects to store inside of here. So it's a framework that could be reused for something, say, other than SRE. The software modeling component is the program I just mentioned before. So it's all of the classes that we've created that are used to model the information that's inside of a program. So a program contains memory, which contains bytes, contains a symbol table, which contains symbols, as well as listing instructions. It's very large, but I think it's modeled pretty good, I think. Plugins. So what I'm speaking about here is the base class for the plugins that are used. So if you wanted to create your own plugin to drop into our framework, this is where the base class and all the base classes live that you would extend from. So the base class is called plugin, and plugins can produce and consume events. So like the screen I showed you before where I had like the 3 windows side by side, how those windows talk together is one plugin will say throw an event, and the other windows will consume that event and respond. So like address changes, location changes, things like that. Plugins are also dependent on each other by decoupling them through a thing we call services. So a plugin will produce a service and other plugins will consume that service. That way plugins are not dependent on each other. So if you wanted to take out, say our go-to service that's inside of Ghidra, which controls the navigation, you could write a new one and provide the go-to service and drop that in, and the rest of the environment would still respond appropriately and work correctly. Plugins are also responsible for managing the GUIs, all the buttons, all the actions. So that's kind of the separation between a script, what I mentioned before, and a plugin. If you want to do anything that's GUI based, you should do it as a plugin, not as a script. Otherwise, you can do anything else in the script. It's kind of our separation on that. Docking windows is our suite of custom GUI components that we've created. So we have, if you're familiar with Java, you know there's J components, there's JTable, JTree. We've extended a whole bunch of those, and we have GTrees and JTables, which are our components to make the environment look similar across Ghidra. So all of our tables look the same, all of our trees look the same, because we use the GTree. So the reason you would want to use that is it gives you things like improved table modeling and tree modeling, which goes back to what Chris was mentioning earlier about needing to scale. So if you have a binary that has 5 million symbols in it, and you're trying to open it in traditional Java GUI components, it would never happen because the table model would not support that. So we have a bunch of threaded models for all of those things. Also does sorting, filtering, gives us a nice uniform look and feel. And yes, it was created to overcome a lot of Java swing sort of wonkiness. So here's an example of that. Going back to the script manager, you can see on the right-hand side is the G table, and the left-hand side is the G tree. And all of those, like the sorting, the filtering, all that stuff is, if you use like one of our G components, you'll kind of get that for free, which saves you a lot of time in doing all the GUI components, like all the development of those. So big question we've got a lot is, why did we pick Java? What were you thinking? That kind of thing. Well, when we started it, Java was very popular, right? It was early 2000. I came on the project, like I said, in 2001. Before we did it in Java, now I wasn't on that, I wasn't involved in that. C++ was tried, but it didn't really give us the platform independent GUI from the start, which is what we needed. And of course, Java gives us a lot of cool features like being able to load classes dynamically. That's how the scripts work. Also gives us extension points. You can drop in new plugins if you write your own plugins, and it'll just load them automatically. Java gives us minimal memory management. It still has some memory link possibles, but now if we started it today, would we still use Java? I think the answer is yes, but we would probably do some things differently. We would certainly make everything be able to be written in, say, Python. So plugins could be written in Python, analyzers, loaders, but one of the cool things that Java gave us from the beginning was, if you have a distribution of Ghidra and you have, say, Eclipse, you can debug that distribution. So if someone was using Ghidra and said, call me up and, hey, Brian, it's not working right on my binary, I could just go to their desk without having to take some big development environment. I could just fire up Eclipse at their desk and debug the source code that we include with Ghidra, just debug it, right in place, and maybe even patch it right there at their desk so they can keep working. And then we can come back and integrate that into our code base later on. So the open source process, let's talk about that. But before we talk about that, let's talk about every version of Ghidra that we've had. Okay, so we started it, say early or late 2000. I came on in, say, mid 2001 is when I joined the team. And when we first started it, yes, it was classified. It was classified because fact of NSA doing SRE was considered classified. Therefore, a tool that does SRE wouldn't inherently be classified. We had our first version 1.0 in 2003. It was mostly proof of concept. It was kind of just getting the framework laid out, the ability to have plugins and analyzers and loaders. It wasn't very good. But in 2004, we came out with version 2, and this was getting a lot better. This is when we added the database and docking windows. So before the database, we were actually just writing out the Java classes to disk. And we had undo from the beginning, but the undo didn't work very well. So by using the database, we were able to do it much easier. The plugins that are layered on top of the database didn't need to know how to undo, which is what happened in 1.0. And we also introduced the docking windows, which was really just the ability to pull the windows out from the main code browser window and move them around, as well as some of the Java components. In 2006, we came out with version 3, which included Slay and the decompiler. So in versions 1 and 2, we didn't have a decompiler yet. You could only disassemble. So in version 3, we introduced the decompiler, and also version control, which is the multi-user, which was layered on top of the database. So because we added the database, we're able to then support and implement something that we wanted to do from the beginning, which was the multi-user collaboration. In 2007, version 4 came out. Two big things that were added to that was the scripting framework, both the Java and the Python, because someone added the Python very quickly after we kind of had some betas of it. Version tracking was also introduced, which is going from version 1 to version 2 of a binary. 2010, we had 5.0. One of the biggest things that was added to that was the file system browser. That was introduced, to deal with the firmware bundles, which were becoming very prevalent. Like before that, it was always just one binary. I want to look at just one binary. But now we have bundles of firmware that you want to look at and be able to tear those apart and bring that into Ghidra. So you didn't have to have have a bunch of different tools to look at it. The big thing though, in 2014, I should say, 6.0 came out, and this was our unclassified version. The reason it changed from classified to unclassified is fact of, like I mentioned before, the fact of NSA doing SRE had become unclassified. Therefore, we were able to declassify Ghidra. But we still weren't ready to release it yet. Over the next 5 years, we worked from the process of unclassifying it to open source. Now, I know you're thinking 5 years, that's a long time, but it wasn't like our full-time job. We were still supporting Ghidra. We had version 7 and version 8 come out with lots of features, lots of bugs, bug fixes, improvements. And then, we were like transitioning to the open source to get there, which, if you may have heard, in 2019, this past March, we were able to finally release the first public version of Ghidra, and the source code was put on GitHub 1 month later. Okay. So I'm gonna give it back to Chris.
All right, I'm back.
He's gonna talk some more about open source.
Okay, so don't get scared. The policy stuff, we're not going to go too deep into this, but thought it would be useful at least to sort of point to a couple government policies that we utilized to kind of help push Ghidra over the finish line, so to speak. And so Executive Order 13691 is one of those. You can see cybersecurity sharing, right? The second bullet, we're able to kind of point to the second bullet and say, look, using the same tool across different groups is really going to improve the ability to share, right? So it makes sense. Here, we're looking at the same binaries. We're all going to look at it the same way. There's not going to be any communication breakdowns. It just seemed like it made sense and we could point to this policy. And then there's voluntary partnering with the federal government. Obviously, if you're using the tool that we wrote, that's going to enable you to work more easily with us. The other policy I wanted to underline here was this open source policy. Now, very large organizations can be inefficient at times, and the government's no different. Keeping track of all the custom software projects that are started up and torn down and released within the federal government at large, it's an enormous effort. And so what this tries to address is some of that inefficiency and make useful custom projects available to the government at large. And so what we did here is sort of point to this and say, look, not everybody works in a classified environment across the government. We make this thing open source, we put it out there, and it's going to be available to more parts within the government as well as external to the government. And it's better overall for all the different groups. We don't have to worry about other agencies trying to build a reverse engineering framework for whatever reason. We've already got one. Now, as Brian said, it took 5 years. Now, what exactly was going on in those 5 years? Well, there's a lot to think about if you're thinking about a large-scale software project like Ghidra, 1 million lines of code or so, and every line's got to be looked at by 2 people. So it's a process we had to go through. It's slow, but not just that. Think about any sort of internal software project that you've got in-house for a decade or more. Never seen the light of day for whatever reason. You got to build it on that old box in the corner. Dependencies, everything is kind of set. And now all of a sudden you want to make it open source so that anybody can download it and build it at home and set it up. That's a lot of effort. So we had to deal with a lot of build scripts, documentation, the process, internal infrastructure had to be stood up to test everything. This was an enormous effort. A number of people were involved. The Ghidra team, public affairs got involved. We've got someone with us today. And OGC, that's the Office of General Counsel, that's lawyers. We had to get involved with them as well. It's a huge team effort. And we're really, really excited that we're able to get it out and be able to do this type of presentation. And so, sort of hearkening to the anniversary of the moon landing, every 50 years or so, the government gets to do something awesome, right? That's kind of what we're pointing out with this. We're not trying to equate releasing an open source project with landing on the moon or anything like that. Ultimately, this was a moonshot for us, though. And when it went down, we had this big build-up, a lot of time, as you saw, to get to that point. We had people on the ground, so to speak, in RSA at the conference, at the booth, waiting for the influx of people to come over and ask questions. We had a big team back home at Mission Control, sort of online, answering online questions, watching the download count tick up. And it was an enormous amount of excitement. We love it, it was great. But why did we do it? Well, we believe that cybersecurity is a big issue, and we want to do as much as we can to kind of help out. And so getting this tool out there is one of those things. But we also really want to embrace the open source community. We love open source. The people that work at NSA are open source type people. We like to be able to give back when we can, as much as we can. It enables us, it enables you, it's a good thing. We're excited about seeing this tool in schools. Trainings are popping up online, YouTube videos. It's being attached to curriculums. We think this is all fantastic. I mean, it doesn't hurt for recruitment purposes, but ultimately, we want to work with open source. We're friends of open source. We're fans of open source. And we want to just show our commitment to the community with this release and our continuing support and engagement. I think it's back to you, Brian.
New features. So we've got some new stuff coming out in 9.1. 9.1 should be coming out soon. I'm not going to say exactly when, but very soon, imminently. And in 9.1, we're going to have some additional processor modules, which are the SLAY specifications. We're going to have, like, say, Super H4, some of the HCS processors. We're going to have support for data type bit fields. This is in for a structure. You can specify bit fields inside of a structure or a union. We've wanted that for a long time. We're also going to have support for syscalls and a SLAY editor. If you want to know more about that, check out the Recon talk that was a few months ago. There were some folks from the Ghidra team who gave a talk on syscall and SLAY editor. Some of the future things we have coming out, no projected release date, is support for the latest Android OAT and ART formats. We're going to have an alpha of our debugger that we're going to hoping to put out so people can use it and see what they think. And we're hoping for some more external engagements, maybe some more bug fixes, kind of working on those together as an open source community. So let's talk about the OAT ART support. So we've kind of just said a bunch of sort of high level stuff. We kind of wanted to show, some VR knowledge on our part for this brief. So currently Ghidra supports the Dalvik-based versions of Android, the DEX executable, the ODEX, which is the optimized Dalvik executable format. We currently have support for those in Ghidra right now. We're going to be adding support for the Bootloader format. This will be in the form of a new G file system for the file system browser. We're going to have support for the natively compiled ODEX files. So ODEX has been overloaded, starting with Lollipop. It actually came out a little before Lollipop, but mostly it was very highly prevalent in version L of Android Lollipop 5.0, where the Java application, instead of being compiled to an optimized or to the Dalvik VM and then optimized as still a Dalvik VM executable, is now compiled natively as an ELF ARM application to run on the device. So we're going to have some analyzers for that, as well as the OAT and the ART formats, and some of the other ones like VDEX and CDEX, which is the verified and compact DEX files. So let's take a look at what this is going to look like. So we're going to have the ability to open the bootloader binary inside of the G file system and pull out the pieces, like the A boot and the secondary bootloader and things like that. So then you can then, from this window, drag them out and drop them into your listing to do some analysis on them. We're also going to have support for the new ODEX format, like I mentioned, which is now the natively compiled application. So what we're looking at right here is two of the magic symbols that are inside of that binary. This is OAT data. This is in the .ro data section. We're going to have some analyzers that will lay down the data structure for that format. And then we're going to use this information to pull out, say, all of the symbol names that are inside of what was the leftover Java VM stuff, which is all the function names and classes. So we can go to the other magic symbol, which is OAT exec, which is in the .text section, and we can analyze the code and lay down all of the data structures that are there, as well as all of the symbol names that were pulled out of the OAT data area. So look for that pretty soon, but I won't say how long because I'm not sure when we'll have it for release. So some metrics. We've gotten a lot more downloads than we would have thought of. We have just over 500,000 downloads. When we had the release go live at RSA, we kind of had an internal sort of bet, but how many downloads you think it'll be? It was my number was way low. I was very just super humbled by the number of downloads that we've gotten. And of course we have a bunch. We've had a lot of pull requests on GitHub, a lot of bug fixes, things like that, which have been awesome. So thank you for that. So some of the public impact, turn it over to Chris. You can talk to this.
I thought we both had something to say here,
okay.
but ultimately I think we've been super impressed with the amount of people who've gotten involved. It's really been beyond our expectations. The number of people that actually learned the SLAY, language and were able to incorporate new processor modules for us was, I don't know, we didn't expect that. We're really, really excited about having more people help us out with the code, finding bugs in the code, reporting problems, and making it better. I mean, part of what we're trying to leverage by entering or getting the tool into the open source community is the creativity and the innovation that you guys can help us with by giving us maybe things we hadn't thought about. Like I was talking about earlier, we may not have thought of a lot of things you guys have probably thought about to do. And so we really want to get as much help from the public as we can with this tool. I think that's one of the biggest
takeaways.
Things that we've got here.
It's a group effort. We all need to work together, to help improve cybersecurity. So this is kind of our contribution. We hope we can, work together more going forward. So thanks for everyone who've worked and collaborated so far. If you want to contact us, the Ghidra team is not on anything but GitHub. So if you want to contact the Ghidra team, you can go out to our GitHub page. We're not on Twitter or anything like that. That may change at some point, but for right now, we're strictly on GitHub. Any new announcements that go out, like when 9.1 is released, that'll be on our NSA Gov Twitter page. There'll be an announcement there. If you have any questions about Ghidra and policy and things, you can contact our Public Affairs Office, PAO. We have someone here now, Liam, sitting up front. If you have questions. And getting Ghidra. You can get it from our official page, which is ghidra-sre.org. That's our official page for downloading the releases. I think there's even a link there to the source code, which is on GitHub. So this is our GitHub page. And so you can download, you can pull the source code there. You can also submit pull requests or ask questions. No other site is official for right now. Those are our only two official sites. Okay, so thanks a lot.
We do have a few minutes for questions. If you'd like to ask a question, please use the microphones in the middle of the room.
Somebody's rolling it?
How did we come in so under? You must have been talking fast.
I don't know, I guess we were. I feel like we were talking slower, but.
I didn't skip anything.
Yeah.
Yeah, I don't feel like we did.
Please use the microphones in the middle of the room if you'd like to ask a question.
Hey all, I have a question here in the center.
I can't see anything. Yeah.
Okay. You explained that you're a big fan of open source software, but I would imagine during that 5-year release process, you ran into some approvers or reviewers who didn't really understand open source software and maybe didn't necessarily want it to be released open source. Can you talk about some of those challenges and how you overcame them?
I couldn't really hear the question. What was the? Could you up?
Was effectively that during the time that you were going through the open source process during those 5 years, that you had to have run into people who didn't necessarily understand open source or who didn't want to, didn't see the value there. There may have been, or must have been some objections. Can you share what those might have been and how you overcame them? I don't think there were really objections per se, but there was more technical challenges for us to figure out because we were excited to be able to start working open source because we hadn't worked that way before. So it was more figuring out like how to best do it from our standpoint because we hadn't worked that way before. So figuring out should we be on GitHub? Should we be Apache 2.0 as their license? All those kinds of things were sort of more the challenges that we had to do.
I have a question here. Here?
I can't really see back there.
So my question is, what resource or documentation do you recommend to become proficient in this tool?
What was the question again? I'm sorry, we can't hear.
What resources or documentation do you recommend to become proficient in this tool?
Outstanding, good question. So inside of the Ghidra distribution, it's also on the Ghidra SRE site, we have
lots of documentation. We have 3 classes. We have a beginner and intermediate class, which is for using Ghidra, you know, how you would manage the projects and importing and disassembling. So that's in the intermediate and beginning classes. We also have an advanced development class, which shows you how to write plugins, analyzers, scripts, all sorts of things to customize the framework. There's also some documentation on writing SLA languages inside of and that's underneath of our distribution under Ghidra docs, Ghidra class. There's a whole bunch of classes there. And of course, if you're a developer, you know, just look at our code. There's lots of examples in the script manager. All of the scripts that are, most of the scripts that are included there are very useful, but they're also there deliberately as examples for how to do things. Like how would you iterate over functions in the listing? How would you lay down functions in the listing? Things like that. So a lot of the scripts there are a great resource to go to find out how to do things.
Thank you.
Sure, thank you.
I have one question. Now with all the positive feedback of open sourcing Ghidra, do you plan to open source any other tool?
With all the positive feedback for open sourcing Ghidra, do you plan to open source another tool?
Sure. But there's nothing that's specifically planned. But NSA in general is hoping to engage more with open source. Absolutely, going forward. Yes.
Thanks.
About this being declassified now, does that mean like all the changes that are submitted in pull requests and so on, you can just work on, or do you still have a lengthy process where it's being approved that you can do something there? And I just wonder how quick this will run.
Could you translate again? I can't hear.
And you're able to take pull requests, I may have to paraphrase, are you able to work with pull requests quickly, or is there still a lengthy approval process for making those tests?
So yeah, so like if we take a look at the metric slide, so like we've gotten, as of the 22nd of July, we said we had 140 pull requests. We still had about 30 open. We're bringing them in as fast as we can, and like we're still trying to also kind of figure out how we're going to work in this new environment. So some of them, if they're small and they're easy to understand what the change is, they may go in quicker. Some of them may take longer. We're still trying to figure that out.
Thank you so much for joining our session.
Thank you, everybody.
Thanks.